This is what you would see if you could look inside your eyes and brain as they respond to a visual stimulus. The stimulus appears on the right side of the binocular visual field. It is detected by retinal neurons in both eyes. All retinal ganglion cell axons stimulated by the right visual field project to the left lateral geniculate nucleus and the left visual cortex. This is because axons from the left half of the right eye cross at the optic chiasm. The stimulus corresponds to the receptive field of a simple cell in the visual cortex. The stimulus is in exactly the right location and contains a bar of light in exactly the right orientation to optimally stimulate this cell. A neighboring simple cell in cortex might be stimulated by a bar of light at a slightly different orientation or at a slightly different location in the visual field. We can examine the response properties of a simple cell in striate cortex by placing a microelectrode next to the cell. The electrode allows us to see and hear action potentials fired by that neuron in response to a stimulus shown on the screen placed before eyes. The action potentials produce deflections on an oscilloscope trace and sound like pops on the audio monitor. Now let's study the response properties of this simple cell. We've already determined its receptive field shape and location. This cell sees the portion of the right visual hemifield represented by the blue rectangle. We know it's a simple cell because it responds best to a bar of light presented at a specific orientation. For example, when the bar of light moves across the receptive field at an orientation opposite to the optimal stimulus, the cell fires no action potentials. In fact, it is inhibited by this stimulus. When the bar is vertical, the cell fires a few action potentials. A bar presented at a slightly oblique angle stimulates the cell even more. The optimal orientation for this simple cell is a diagonal bar at an orientation exactly opposite to the one that inhibited it. This stimulus causes the maximum number of action potentials. Turning the bar to a slightly new angle diminishes the cell's firing rate. A horizontal bar produces very few action potentials, but it does not inhibit the cell from firing.